what we decided to do was create this event, which is a knowledge sharing event essentially, and it gives you the platform to present what your company is able to do, what solutions it offers, and the challenges that we loaded on Leo, uploaded onto the Leo platform, actually hopefully prompted you to then respond with the appropriate kind of presentation today. So on this call, we've invited various of our industry technical people, subject matter experts, senior managers, and interested parties, so that they could be exposed to the offerings and the solutions that you have, with the intention of then engaging with yourselves directly after this event or through our technical steering committees, RTIMS being one of the programs, and then we have the other programs as well. I see some of the program managers are on this call, and then engage further afterwards. So with that, I'd like to just open the floor to the presentations. But before we do so, any comments or questions for background or clarification purposes? Okay, so I don't see any. Kim.
Just very quickly, are we able to share screen and show slides?
Yes, you should be able to. In fact, we'd like you to.
Yes.
So Zandisa, let's just check that setting is available to Kim. All right. So with that, I'd like to kick off then with you, Kim Chandler McDonald. Will you do the intro for yourself, and then Kidek, please ask the presenters to keep to the timelines that we've provided on the agenda. And there will be a Q&A as well after each presentation. So with that, I'd like to hand over to Kim. It's all yours. Thank you.
Thank you. And I'll also ask my co-founder, Michael McDonald, to open up his video and microphone. So yes, we are Kim and Michael McDonald, and we are the founders of Flat World Integration, which is a consulting firm focused on solution architecture and deep tech innovation. Over a number of years of R&D, we've developed Flat World, which is a data platform that enables users to integrate, mitigate, and control their data at scale from any source and in any format. It is across the increasingly stringent cyber, data security, and compliance demands that are being placed upon businesses. So users can integrate data with Flat World from APIs, systems, processes, and applications securely and easily. I'm sorry?
Can you see my slides?
Sorry, we're in different rooms, so we're making sure we've got the correct slides up. And that's a great slide to be on, Michael, because it does discuss the problems that Flat World solves. So essentially, users can integrate data from APIs and systems, processes, and applications. They do this securely and easily, so that regardless of whether it's sharing between departments or business units, partners, companies, supply chain members, using Flat World's no-code UX or through APIs. And Flat World has fine-grained data sharing and real-time data monitoring, which enables users to mitigate data risk by controlling at a granular level who can see what and when, and logging what has been seen by who and what they may or may not have done. And in the midst of collaboration, that kind of transparency we see as being increasingly important. It also controls and enables fast, reactive, and or proactive actions to be taken when necessary because of its real-time capabilities. It's easy to use and implementable in a few hours. So it enables businesses and organizations in essentially a digital and data economy to work together in real time in a trusted way. So, Mike, would you go on to the next slide, please? Rather than, as the slide says, rather than adapt traditional technologies that essentially have clustered around essentially what they call data integration, we have decided that integration is just a small part of the issues around really data interoperability, particularly if the data is going to be used multi-jurisdictionally. For instance, we enable the engagement between different levels of organizations. Also, we are simple to use because in a supply chain, it may be that one organization can afford a very expensive and robust piece of technology and others cannot. So Flatworld is vendor neutral and platform agnostic. Michael, do you want to go on for me, please? Next slide. Out of the box, you can bring together the data, as I said, in any format from disparate systems, and you can do this in a way that is very scalable. I'm going to have Michael talk to the technology itself, but I think also particularly given that the mining industry is becoming so aware of essentially the social contract with regards to being environmentally aware, the fact that Flatworld has such a minimal carbon footprint, I think is also important to note. And Michael, will you move on? We will share copies of this slide pack. So if you would like to have more time to read it, please do let us know. Michael, I'm going to introduce you now, and if you want to take over. Michael is my co-founder. He's also the CTO and truly a world leader with regards to solution architecture. And when we began this journey a number of years ago, we were told that essentially we were solving a problem that was impossible. We were told that actually by one of the fathers of the internet. So yes, it took us quite a long time to actually get through the R&D and get something that not only worked, but that worked simply and quickly. And that was a real challenge. And kudos to Michael for taking us there. And I'll hand over now.
Okay. Hi, everybody. Just hang on. I'll stop sharing this tab and I'll start sharing the demo tab. Okay, I'll share, use Teams. Okay. All right. Can you see that, Kim? Yeah. Can you?
Sorry about that. I was on mute. Yes, I can see it.
All right. No worries. Good. Okay. So just to give a background, I have over 30 years experience dealing with very big data at very big scales in a lot of different industries, from telco through to defense through to finance, resources. This technology is designed upon a lot of market research and a lot of experience in these different industries and looking at the problems around data at scale. So let's go through the technology very briefly to show you what we've done here. It's what you're looking at the moment is just a user interface, which is essentially communicating with the back end. Flatworld itself is essentially a data infrastructure platform for distributed data at scale. It's designed to be horizontally scalable. It really works on very small platforms, i.e. PCs, right up to huge Kubernetes clusters. It's also designed for multi-jurisdictional data sharing. What that means is you might need to be able to keep data in different geographic parts of the world and have them sharing under very controlled circumstances based upon reasonably complex rules. It's also designed for essentially industrial use as well, so it integrates seamlessly with existing enterprise arrangements like single sign-on. And it's also designed to be extremely cost efficient. So the business model and the operational model and the technology stack that we use is specifically built to give you essentially the cheapest result for everything you need around the data sharing and the total package around that. So it's actually a game change in terms of cost, and it's also a game change in terms of how easy it is to deploy and how to use it. So what I've got here on this screen is just showing the core concept of what the technology uses. It's around data containers. Data container can be simply thought about your own secure container, which is created for you automatically by the technology. It handles all of the encryption behind the scenes for that. in that data container, you can put many different data files, as we call them, into it. So as part of what we've seen as being the major friction around trying to share data at scale, is essentially, first of all, you need to have a very simple way of getting data onto the platform. So the platform enables API connections, just drag and drop with file sharing, all those different things like that. But on top of that, it handles a whole bunch of things that you would normally have to code for yourself. For example, you can see here, I loaded a whole bunch of different types of data onto the platform, and it automatically converts this data into a vendor-neutral format, which can be used to slice and dice and share and actually transform into different formats as is required by the use case. So we've got everything from here, from XSL to CSV, PDF documents. We've got IoT sensor data, we've got Slack conversations, and obviously it's documents. The technology itself handles structured, semi-structured, unstructured data automatically. So if we go and have a look at the PDF document, you see that data is automatically extracted from the PDF document and surfaced in a way that can then be used by either AI, ML, or alternatively, you can just download the PDF document like a Dropbox type scenario. This is quite useful for essentially doing a lot of text processing. But what we also have is if we're looking at things like Slack conversations. Some of the data now is quite difficult to process, especially things like Slack and IoT sensors. You have a lot of JSON, but it's time series JSON. And it also can be variable format files coming through. The technology automatically analyzes the data that's coming onto the platform and automatically adjusts the analysis of the data. So for example, data structure changes dynamically over time, or alternatively, so it's a variable format file that we're getting. The platform automatically handles essentially the analysis of that data and the processing of the new revised data structure. The ability to do this allows you to combine essentially very disparate types of data automatically. So everything from, like I said, Excel, CSV, all those different data types, structured, unstructured, can then be handled on this platform without the consumer of the data doing anything. When we put it into this format, we have two options. We can either essentially save any of these data sets down into JSON, to XML, to CSV, or to Excel format. Alternatively, we can just download them as essentially the raw data that was loaded onto the platform. We also have a whole bunch of tools here to manage the data, so we can rename fields, change the order of data sets, join them with different data sets, and also filter them selectively. So that's handled automatically. The other key component of the platform is sharing of the data itself. So beyond essentially getting the data onto the platform very easily in a real-time fashion, like that was just updated once, but this could be real-time data streams, you need to be able to share the data very simply and easily with anybody wanting to consume the data, but obviously with control. So what we've got, the platform itself has all the sharing functionality built in. So for example, we're sharing all of those data sets that we uploaded. From this, I'll just pick one of them at random, so details. So this is a sharing certificate with I share it with the company-wide department here. You can share the data as many times as you want, i.e. you load the data once, share and slice and dice as many times as you want. It stops the kind of the SFTP type scenarios where you always have point-to-point, you've got to always set it up for the individual connections. It also means you only upload one source of record, and then you can share that as many times as you want. From that, you normally want to consume the data either by downloading it in a different format. For example, you can download it in different formats here. Alternatively, you might want to just have a URL that you can use in other platforms for ML, the data science workflows. You typically want a URL to download the data sets. Alternatively, you might just want to be able to share the data with a user. So you can just copy the URL to that, put it into the browser. I think I want to reshare this screen. I'm not sure if it's being shared. Can you see this, Kim? Just saying, I was just seeing if you can actually see what I'm sharing at the moment. Yeah. Cannot? Okay, just hang on, I'll stop sharing. I'll share this particular tab. See the whole window, might be easier. Okay. So just with that URL, what happens there is the technology will just obviously bring up a window that a user can interact with. So this type of functionality allows you to create sharing scenarios in real time. Also, automatically, it's recording what you're doing in real time as well. The entire system, can you just check? You can see. The system is recording all of the data interactions as to who's looking at what, who has access to what, and what is actually happening. So in this scenario, you can actually control in real time and mitigate in real time what is actually going on. These messages can be sent to a CISO, for example, to a platform if you're looking at things from that perspective. And from that, as I said, the real-time nature of the platform is you can simply say, we don't like the behavior, so we will simply stop sharing this data. And it's as simple as that. So this is also can be controlled by APIs and code. The entire platform is designed to be very low friction, i.e. just put it in, you get up and running almost straight away. For example, to put the data onto the platform took this much code. So it took 2 lines of code, literally, to connect to the platform, load the data, and share the data with the new company. Also, from a postman perspective, which is essentially another way of communicating via REST APIs, it provides very simple ways to interact with the platform. The whole concept of this platform is low friction while maintaining security. The security can be as tight or as casual as the use dictates. And that's really about it. Yeah, I said the work's really designed on getting the results you're after, being able to satisfy all the compliance regulations. Said before, this technology behind the scenes can handle multi-jurisdictional data sharing, so you can share between different regions. You can have multiple flatworlds running in different companies. So you might have to have scenarios where you've got to run behind the firewall for whatever reason, or you might have contractual or legal reasons as to why you need to run things in certain places. So it's designed for those scenarios. So that's pretty much it. Sorry, I was been a bit over time on that. It always seems shorter in your mind. Beyond that, we've mapped out a few challenges that we've dealt with a few times, which is really around data sharing again at scale. We have not dealt with the mining sector specifically, but I said before, we've dealt with the healthcare scenarios, and we've dealt a lot with telco, finance, defense, and other scenarios there. In terms of the team,
we certainly have thought about the mining sector, though. If you could go back to that slide, Michael, just quickly. I think it's slide 8. Yes. Yeah, so noting that essentially the mining sector is one of the most integrated and also in many respects technologically advanced with regards to AI and sensors. We certainly have thought a lot about the sector, and so we have created an example wherein we see a potential use case.
Yeah, and we do a lot of work with US as well, like things with generative AI and stuff like that. So the technology is, like I said, designed to integrate into essentially any work tool / workflow environment, and also designed to remove the friction that you'd either have to normally deal with coding or bespoke tooling. And this allows you to actually handle all of the data sharing holistically at scale without any real complexity about having to understand the mental map behind this and or really know a lot about the platform to use. So again, with that,
I think as well that the fact that there's a very low adoption curve, no expertise is really needed, and it fits in with whatever legacy systems are within an organization is quite likely to be of interest.
Absolutely. So it is designed to operate within legacy environments, and in most environments, using say most integration methods are SFTP or email and things like that. So it's designed to fit into those environments and lift and shift them to a way where you can actually get a lot more value out of your data, make it far more useful. But at the same time, you have far more control and visibility as to what's going on, and you're able to manage it holistically. It becomes a less fragmented challenge, which it typically is, especially for CISOs these days. It allows you to actually allow that to mitigate, get between essentially the raw data where it's coming from and the people who want to consume it. Gives you that way of interacting, putting in a layer in between those two things, which is very low friction to deal with that. So again, apologies, I think I ran a bit over time, but thank you for your time, and I'll stop sharing.
Thank you, Michael. Thank you, Kim. From our audience, any comments or questions? I don't see any hands. How would you engage with a client, a new client? Do you do a proof of concept, or
Probably a proof of
what is your approach?
Well, normally it's, first of all, it's working out, just clarifying the scenario itself. For example, we're doing one at the moment, which is Salesforce migration between a whole bunch of different systems in a very secure environment. So it's really giving the framework for essentially how to do that between the different systems. How do you approach moving data with controls onto a new platform, working out exactly how we're going to map between the two different platforms, and then just simply, to your point, proof of concept. So literally, you've got 2 to 3 days to show a result, and that's what we do.
Okay. Good.
Right.
Anything from anybody? Any questions? No.
Okay. Thank you for your time.
Pleasure to meet you all.
Thank you.
Absolutely.
Good.
Yeah.
Just want to put the agenda back up. Zandise, will you put the agenda? Yeah, thank you. Oh, good. I have too many screens open. So our next presenter is Rupert Birch and Sergey Reznichenko. I hope I pronounced that correctly.
Absolutely.
Good, thank you. Over to you.
Thank you, JJ, for that. And good morning, everyone. As JJ so eloquently put it, my name is Rupert Birch, and I'm presenting here this morning with Sergey Reznichenko. I think JJ did a better job of pronouncing that. What I'm just going to do is I'm going to pull up my screen, and if you can just let me know, Sergey, when we are. Can you see our screen okay, Sergey, which infers everyone else can? That's yes. Okay, fantastic.
Yes.
Well, good morning again, everyone. So today, SitePower and ourselves, Ramjack, are going to give you an insight into a holistic shaft scanning solution that we are in the processes of putting together. But before, sorry, I get too stuck in, I wanted to provide you a few slides of the background to our approach to this actual collaboration. So Ramjack, as some of you may well know, is a systems integrator focused on the mining industry. So we are well versed at understanding the strategic imperatives of our clients and pulling together systems and solutions that will actually address those specific issues. We're very much part of understanding and proposing, as opposed to trying to pitch you round pegs for your square holes. SitePower has a similar background and collaboration, view to collaboration. And maybe, Sergey, you can give a quick minute on the background to SitePower.
SitePower, first of all, good morning, everyone, or good afternoon already. SitePower has a similar profile to Ramjack. We, technology company, we develop our own technology, both hardware and software, and from development to implementation to the industry. Like we propose them. Also, we don't sell the products, we propose the solutions, and one of these solutions we're going to present today, very briefly.
And so this slide here, I think, sums everything that Sergey and I have briefly touched upon. We're owner-operators of our respective businesses. We have buy-in from our partners from an equity perspective. We have a global presence, so we are able to bring our expertise and experiences from across the globe to any market that we're operating in. But equally, we're very pragmatic. in how we approach solutions. In that we're actually looking for something that's going to fit that square peg of yours. And a point to highlight, especially for I believe the audience in the Mandela mining precinct, is whilst I'm quite clearly not South African, although I have been accused of being South African in the past. I'm actually stepping in for Mike Jackson, the CEO of Ramjack, which is a South African-based company. Mike himself is actually Canadian, but is a major owner of the Ramjack Technology Solutions in South Africa. And we have the Canadian flag here because there's a very close linkage between South Africa and Canada, not only from a mining perspective, but also technology share, so on and so forth. And certainly on the site power side, we have a similar story. A Canadian company, but with a big footprint here in South Africa. Sergey himself is based in Johannesburg. So we believe certainly for this presentation, it's important to put across the fact that you're dealing with very much a South African entity or entities, and but we're bringing together a very global expertise to this. So what I want to do with this slide is to hand over to Sergey. What we're looking to do, as I said, is present the concept of operations to automate the shaft inspection process with the ultimate goal of improving health and safety and at the same time productivity. So Sergey, if I can hand over to you, please.
Thank you, Rupert. And yes, actually Site Power started as a company 13 years ago with the ultimate goal to develop automated shaft inspection technology. But a few years down the line, the project, for some reasons beyond our control, had a big hiatus of about 7-8 years, and now we decided to resurrect this project again. I don't want to dwell a lot on the maybe on what is shaft inspection. I mean, mining people, they know very well that every week at least you have to send people down the shaft to inspect the condition of steelworks, ropes, shaft lining, and so on, everything what fits inside the shaft, and on surface as well, all that winders and headgears and so on. It's so far the inspection is done the same way it was done almost 2,000 years ago by Romans or Greeks. People go down the shaft, they visually inspect the things. Obviously now they've got different tools like laser rulers and digital cameras, but in terms of the principle of inspection is still the same. It's subjective, it's time consuming, it takes a shift at least, and for the whole shift there's no production. The mine has to be stopped. It's dangerous, and the data manipulation, and mostly it's manually, and again, data interpretation, it's subjective. What we tried to do, we proposed to automate the whole project from data collection and then to data processing and analytics, and then presenting the result in the cognitive format for shaft engineers, for people to make a conscious decision. Okay, can I ask you, Rupert, move to the next slide? Yes, it's just a few of the benefits you can get with automated shaft inspection. I forgot to mention our shaft inspection based on the mobile laser scanning. So it's a system which consists of a few components. One of them is a laser scanners. Another important component, it's some sort of gyroscope or inertial management unit, but there are obviously some other things as well, some other components as well too. What we say, two most benefits, most important benefits from automated shaft inspection. First of all, it's safety, both in terms of the people not being sent to the dangerous environment, and secondly, the system can pick up the small defects or small discrepancies before they manifest itself and result in some serious downtime or some serious accidents. So it's a safety both for people and for the mine, and obviously we cut down significantly in the time of inspection, so your hoisting availability increases, so the mine can produce more metals to hoist more ore, so obviously it's to realize higher revenue. And again, maybe legally, you've got all your shaft inspections logs recorded and presented for any inspections. Again, it saves a lot of time for the shaft engineer to explain to inspector of mines what went wrong or it didn't went wrong. So it's also a big issue now in South African mining industry, especially with deep mines and deep shafts. Okay, next slide, Rupert. As I said, the company started 30 years ago to develop that technology, and the project was alive for 3 years. During this time, we built the prototype unit. You can see that unit in the left bottom of your slides. And again, the technology consists of two main parts. It's hardware, of course, and then software to process the data, to visualize it, to analyze the data, and so on. So we, as I said, for some reasons, legal issues with our partners, that time it was Shaft Sinkers, you know, it was biggest global shaft sinking company. They were our partners in developing this technology. In 2015, Shaft Sinkers went bankrupt and the project was stopped because of IP issues and so on. Shaft Sinkers had to be liquidated. But we bought all the IP for this technology. Site Power owns the whole IP. And as I said, we decided to resurrect this project. Okay. Rupert, next slide.
So I just wanted to step in quickly to add to what Sergey has been saying. One of the reasons Ramjack and Site Power work so well together is the ability to collaborate on our different respective expertise. So Ramjack has purchased a number of technologies which are shown here. One is drones, handhelds, and vehicle-based mobile scanning solutions. So by team is providing holistic capabilities to bring together the hardware knowledge and background and expertise of Ramjack with the software data manipulation expertise and background of Site Power. So we believe that together this is a very strong collaborative group, and that's one of the reasons we're very keen to present to organizations such as the Mandela Mining Precinct.
Okay, as I mentioned already, we propose the like one-stop shop solution. There are a few companies on the market who sort of offering shaft scanning as a tool, but they don't go beyond the scanning. We believe it's because shaft inspection is quite a complicated thing, and as I said, Site Power Ramjack, we propose the entire holistic solution from building theoretical model of the shaft to laser scanning and data processing, data post-processing, data visualization, including like mixed reality or holographic visualization, where you can actually, shaft engineer can position himself inside the shaft from the comfort of his office and do all inspections like sitting in the chair, but immersing itself into underground environment. And then it goes to job card issues, shaft scroll log, and so on. So we, as I said, it's an entire solution which covers the whole value chain of any hosting operations. Okay. Just to show you some of the examples, it's a different projects we've done over the years. So as I said, technology has been developed and it exists. It's not commercialized yet, but nevertheless, we managed to complete or accomplish few projects. Just an example of it, that was shaft under construction. There was a serious issue with the lining deformation, and we scanned that shaft, and then they did all the analytics to analyze actually every tubbing ring, and then the whole shaft to perform the whole shaft deformation analysis. And here, just few pictures from our software. Yeah. Next. There was another shaft, basically actually in South Africa. Also, there was a critical failure of some lining due to the geological anomaly. Again, the shaft was scanned, actually a section of the shaft was scanned, and we performed analysis of the damaged zone of the shaft. Again, as you can see, the whole section of that shaft has been modeled in 3D. From the point cloud, our software extracted element and reconstruct. It's actually what we call it, or people now call artificial intelligence or machine learning. You actually teach software to recognize within that point cloud what belongs to what, and actually software automatically builds all the steelworks and classified whether it's a ponton or guide or it's lining and so on, and then it does like defect detection analysis. Okay, and you can see some of the results of that. Another project also done in South Africa. It's involved different hardware. It's actually maybe alluding to that slide. What Rupert said when the Ramjack can have a different platform to scan it, actually to obtain data. That was done with, as I said, with drones and some static laser scanning. Again, the task was to scan all headgears and do the deformation analysis. And it was done within our software. So the software was the same, just the scanning device was different. Okay. Rupert, do you want to say a couple of words? I can say it's actually, maybe, yeah, I'll start it.
Sergey, I think yes, you can go.
Yes, up to the date, the site power spent about $3 million to develop the technology to the technology readiness level of 6 to 7 out of the standard classification, TRL classification, and 9 is it's fully commercially available. Last quarter, Site Power won the grant from MICA. It's Mining Innovation Commercialization Accelerator. It's Canadian, I would say, equivalent to Mandela Mining Precinct, which is funded partially by industry and partially by the government. Actually, the government matches what industry puts forward. And yeah, Site Power, that was a grant we received last quarter, and the project is supposed to start this quarter. That grant will not cover what all we need to fully commercialize the technology. And yes, we're looking for another 20 million rand or equivalent to be able to deliver turnkey solution to any mining companies with deep shafts. And also we need a looking partnership in terms from the mining companies in terms of the development of test sites, where we have to trial the technology and then fine tune it, obviously. Yes, that's what I wanted to say. Rupert, maybe you want to add something.
Sure, and I think thanks, Sergey, for letting me talk a bit on this slide. I think that the two most important parts are the final 2 points. Well, no, they're not really, because the MICA is equivalent to Mandela Mining Precinct in Canada. They've seen the value of the proposition that's been put together here. Obviously, Canada is home to a lot of shafts, but so too is South Africa. So we see this partnership between South Africa and Canada as extremely strong, and a way to really bolster not only the funding that come out of Canada, but also the technology know-how, and marry it to the capabilities in South Africa. And then in terms of the actual development sites, I think what Sergey and I are keen to raise is the importance of engagement with the industry, to actually work hand in hand with partners who are willing to work with us, to actually lend their time, their property, if you like, to test, develop, prove up the technology that theoretically we know works. It's just a matter of actually putting it to the test. So we see Mandela Mining Precinct as an important partner on this, and hope certainly as a result of this presentation we can engage with a number of parties who would like to see if this is something we can make a reality. And I think as an indication, this next slide, Sergey, you're better to talk to, kind of just gives you an understanding the kind of timeframes and deliverables that will occur over the next 18 months or so.
That's yeah, thank you, Robert. That's exact copy of the slide we presented to MICA, and it shows the break. And according to this slide, the project will be funded, and we envisage 18 months to complete the commercialization of this technology. And it just shows the breakdown of what's equipment, obviously it's hardware, and then labor. It's both for system integration and for software development and productization. Yeah. So the project is supposed to start and will start this quarter, and it will end end of next year.
And sorry, just to talk over you, Sergey, I think our final slide here is just to give you an understanding of the kind of the extent of the client base that both SitePower and Ramjack have worked with over the years. You'll see there are a number of Southern African operations here, as well as operations based around the world. So we certainly, as I said, bring a lot of expertise and local knowledge from around the world. And this is why we think the partnership between SitePower and Ramjack is so powerful for the purposes of this project. So thank you again for the opportunity, JJ, to present. I hope there are some questions we can entertain.
Thank you, Sergey and Rupert. Very interesting. Question from my side is the TRL levels, 6 to 7, you indicated. So the funding that you require would progress it to TRL 9, or what else needs to be done if we consider the TRL 6 and 7 levels?
Yes, we're talking about full commercialization, so it's TRL 9, yes. You saw it as a slide. I showed the prototype we built 10 years ago. Nowadays, if you compare your cell phone 10 years ago and now, similar things happen to any other electronic devices. At the moment, we changed the thinking completely, and that new scanning system will be modular, will be much more compact, and will much more small, of course. So because there are new lasers on the market, new IMU inertial gyros on the market, and so on. Also, for this new hardware components, we have to write new embedded software to synchronize all the new parts, and we have to, on the software side, actually, software development never stopped, and we did a lot of advanced our software quite a lot. And for instance, that holographic visualization or immersive visualization, it's one of the things we developed over the last few years. But it's not productorized. Sorry, it needs to be commercialized. So it's not only ourselves can do data analysis and processing, but any person or any company who buys that system should be able to do it themselves. So that's what we're looking for, sort of, to move from level 6, 7 to level 9.
Great. I see a hand there from Duncan. Hello, Duncan. Welcome.
Hi. Thank you. Thank you for the presentation. Very good. I just wanted to know, are you able to render all the results in real time, or what is the delay between you scanning in the shaft and actually people being able to see and use the data? You I think alluded to the fact that an engineer could sit in his office. I'm assuming it would be ultimately in real time that you'll be able to look.
Look, almost in real time. You still, even software, as I said, has elements of AI and machine learning. We believe we can do it within an hour. So once the data is available, it will take our system about an hour to do all the processing, data processing, and detect all the changes, classify all the defects they found, compared to your previous slide, and with your baseline model. So yes, within an hour, you will have a full report.
Thank you.
Actually, the system,
what stops it from producing information in real time?
No,
or let's say near real time, which is maybe
near
minutes
real
away,
time,
as opposed to an hour.
Let's put it this way. We deal with the data. We're talking about terabytes of data, because the system creates a point cloud of tens of billions of points. Okay, we don't have a problem of processing this within our software, to processing this point cloud, but it still takes some time. Okay, again, how the system works, it's actually it's processed the data, and then it highlights all the changes it found to the shaft engineer. So shaft engineer can go and actually go through all the highlights, changes the system found, and then ultimate decision still for the person to decide whether it's some damage, it must be immediately repaired, or it can wait for the next week, or can wait for regular maintenance, and so on. So that's why I'm saying it's 1 hour, because it's a process. in terms, also, we were thinking it's when the system goes down and up, it's actually generates the data. So you can, one thing is to transfer that immediately to the shaft engineer office, or rather than it comes to the surface, it uploads all the data to a special folder, and then our software works with the post-processing and data analytics. But as I said, just within an hour, it could be, I would say 15 minutes, could be half an hour. So it's almost real time, but it's not like a, you still need times for post-processing and some analytics. Yeah.
Great. Good. Thank you, Sergey. I don't see any other hands, comments in the chat. Let me just check.
We have a much more comprehensive presentation, more detailed, okay, which not just few slides as we showed now. Even we can give you a live demo of some projects and how the system works. If some people are interested, it can be arranged, no problem.
Great, thank you for that. So if we don't have any more questions or comments, and for our audience, those who maybe are reflecting on what's just been presented from the last two presentations, if you do have questions, or yeah, it's you know, sometimes we think about things a bit later than after the presentation. Maybe you can post the questions then, or you can raise your hands later on as well, and we can refer back. With that, Sandize, I'd like to present, to introduce our next speaker. So if you can just put the agenda up. Okay, so we have Alpesh, who will take us or explain to us what they do and how they do it. Hello. And what they have on offer. Thank you, Alpesh. It's over to you. Yes.
Can you hear me okay, everybody? Yes, JJ, can you hear me?
Yes,
oh,
I can hear you.
Hi, I'm Alpesh Doshi. I'm based in London. I'm a co-founder of one of our companies called Kendra Labs. Going back to the briefing sessions that we had. Oh, let me share my slides. 1 second. Let me just share the page. Hold on a sec. Can you see the screen?
Yes, I see it now.
You can see it now, can you? Oh, it's a bit weird. I don't see the screen on my screen. Okay, well, can all of you see my screen?
It's okay. We'll tell you what's on your slide.
Okay. So it should say Introduction to Kendra Labs, an open source cloud native data platform. Fantastic. Okay. I don't see it on my team screen, so I don't know. So I'm going to talk through just about going back to some of the requirements that I heard. Let me replay the requirements that I heard. You know, you're looking at the whole data lifecycle around data, around collection, capturing, and transferring information in real time across the different companies, and being able to take smart decisions and reporting, and be able to improve the efficiency and safety of mining. So for us, what we've seen across our work, Fintricity is my group company. We've been around for 20 years, been working in the data and AI space for that long. What we've seen is the complexity of how you build data platforms has changed over the next few years. But what we've done is, our focus is real time and our focus is open source. So these days you can build an open source platform for real time data and for real time processing. And I'm just going to go through what we're doing in that space. Oops, so I'm hoping, there we go. So the key problem that we're solving is to enable companies to leverage data and AI across their business and be able to have integrated data and be able to handle that data across many different processes and applications. So some of the things that we see, what we see a lot of is BI and reporting. So we see a lot of companies saying we want a dashboard. But actually, what we're talking about and what seems to be happening is shifting from just building dashboards to actually building what we call data applications. And data applications could be anything. It could be making decisions in the mine on an app, or it could be making purchasing decisions. All of that requires data. All of that requires modeling. And what we're doing is providing the sort of core platform to do that. And be able to then deliver those flexible, scalable applications. And the whole of our platform is open source. and we leverage and build on open source technologies. So what are the principles of a modern data stack? I'm going to try to avoid, because from my research on the audience today, most of you aren't technologists. So I'm trying to avoid speaking techie, but I'm hoping that hopefully most of you will understand what I'm trying to say. So the principles of building a modern data stack are those, you can see them here. We believe in open source, and you can actually now create open source technologies and open source stacks based upon industrial strength technologies. And these technologies come out of companies that you would know, like Uber and Airbnb and LinkedIn and Microsoft and a whole bunch of others. So the kind of technology, a lot of time people think open source and not reliable, but actually open source technology has come out of some of these biggest companies in the world who've built it themselves and decided to open source it because of the fact that they've all used open source in their businesses and they're contributing back to the community. What we've also seen is every company is different. So being able to configure a solution that's not a particular type solution, being able to configure it the way you want, being able to handle data pipelines. One of the biggest challenges is how do I bring all the data in? How do I manipulate that and use it and then expose that to many different places, including reporting, including building applications. Be able to orchestrate that data, be able to do things as the data goes through the pipeline and change things, run models on stuff and store it and use it. Obviously, what we're seeing with things like generative AI and ChatGPT, hopefully some of you know about that. That again, that is now transforming how data is used to answer questions in simple terms. If you have a problem or a problem or a solution you're looking for today, you would have to spend days researching it. With new AI modeling like generative AI and large language models, you can actually ask it a question. And if you guys have used ChatGPT, you'll know the power of that. So think about that in your organization. How can you take all the data across your organization and be able to channel it so that anybody can ask a question and it'll get the answer in the context of your organization? On the right-hand side, I've mentioned open data standards. So we believe in open data standards. And the mining industry, there are actually a suite of different open data standards that exist. And obviously, for us, open data standards are the way to go. You don't want to build proprietary standards around this. You want open data standards. One of the key areas that we see companies, every company is going to look at is sustainability. So Kendra Labs, one of the solutions we're building is around sustainability and being able to embed that sustainability stuff into every part of your business. And I've got to mention security and governance. So the whole stack and the whole solution has to be secure and has to have data governance and governance around the solution itself. So going back to what I said about building data-driven applications, what we see is the future of using data in the business is to build data-driven applications. So taking all the disparate data sources, and then you may want to build an app by, let's say you have 10 data pools. You want to take those data pools, rather than merging them all into one place, you want to take those data pools and then use those data pools to build an application, and all the complexity is hidden away. So the user of the builder of the application can easily do it, and they don't have to understand how all of the different spaghetti and technologies and platforms all work at the back end on how to actually expose that data to be able to build that app. And so for us, it's really important to build those things. Other things in here around data layers. So what we see is most companies of any size will have multiple data sources. The challenge of merging data sources is a really, really big challenge, and being able to say, actually, you don't have to worry about that. It's hidden away and abstracted away. The complexity is abstracted away is a really important part for us to help deliver for companies. And so if you go through the life cycle from data collection, I think one of the key things you're looking at is real-time data collection and IoT-based devices, being able to bring that data in and process it in real time, store it, even to the extent that you might want to take an action on that real-time data at that point in time. That needs to be able to be done in a single platform, in a single stack. So for us, you've got to be able to do that. Things like data storage, in mining and as in other industries, you're going to generate humongous amounts of data. Be able to store it, manipulate it, connect it, and use it effectively is a really important part of delivering that solution. For us, one of the things we do is provide the solution, provide the complexity. Integration is absolutely key, and some of the other speakers have talked about it. And then the two most important things for me on the right-hand side are building those data applications, being able to do visualizations, reporting, and be able to have a scalable, cost-effective solution is really important. And for us, we use cloud data platforms to do that, like AWS. And so this is a technical slide. Apologize. I don't intend it to be technical, but what we do is we take modern architecture. So I'm a technology architect by background, and use that to build a solution. So cloud native means being able to, rather than have a server which is on the cloud, you basically use components, and those components can be assembled and put together, which are called microservices. And there's a modern idea of what's called a data mesh, and all the things I'm describing around hiding away complexity, hiding away all the different pieces and how they connect together, is what's called a data mesh. And I can talk about that for hours. And one of the key things we do is implement those data meshes in organizations.
So yeah, you're gonna be watering your garden, doing all the other work.
Sorry, is that a question? Sorry. So some of the key things is if you're talking about data and data science, how do you go through the life cycle? So our system and our solution goes from data sampling all the way to building those solutions, including things like model training and validation. And if you're just doing analytics, this is fine. You can get just dashboards and reporting as well, and you can see that. So to build this is actually pretty complex. So what we've seen in companies can spend anywhere from 6 months to 2 years trying to build this. And we've built these things for customers before, and we realize this is crazy. Why would somebody want to build this stuff from scratch every time? So being able to provide a complex platform in a simple way to be able to use really relatively quickly is something that we help try and solve. Secondly, to actually assemble the skills to do this is actually quite a lot. There's a load of different types of skills you need. As you can see, data engineers, DevOps engineers, data scientists, software engineers, business analysts. To assemble that team to be able to do all those pieces is pretty hard. And finally, it's a multi-year project to deliver this. What we're trying to do is reduce the time to market and reduce the time to productive use, especially when you're talking about real-time applications to scale. So what users do we serve? We serve users who are analysts and data scientists. They're business users who want to use the applications. We serve the software engineers and app developers, so hiding away complexity on how the data platform works, and enabling software engineers to build those applications quickly, so they don't have to understand where the data is, how it works, where the data is integrated. They can just start using APIs to be able to do that. And then running and operating that needs a DevOps operations team. And again, we try to simplify that infrastructure, because as you scale, you need a whole bunch of support at the back end to run and operate and run and maintain the actual platform. So being able to do that is something is really important, to try to simplify that. And we provide both the people to do it, but also the technology and the platform to simplify it as well. And so this is just an example of a life cycle, which I've sort of described to you, but collecting data, preparing and mapping data, building and training the data to scale, and automating and deploying to production. What we're doing is using open source technologies to build and deliver that. Going back to data mesh architecture, just a picture just to give you an example of how it works. So you've got the data sources on the left-hand side coming in. You put those data sources not in one place, it could be 10 data stores, because different types of data are stored in different sources. So if you've got time series data, which is a time and a value, you'll use one type of data store. If you've got structured data in a database format, you put it in a database. If you've got documents like one of the previous speakers, like PDF files and other things, you'll store them in a different data store. You'll need all those data stores. And then what you do is you work out what are called domains. So you have a customer domain, let's say, and that customer domain data is pulled together and delivered as a product, a data product, which then can be used on a consumer, and that could be a dashboard, that could be a data application. And so what we do is integrate that stuff together so you can actually build those applications rapidly and quickly. So this is just an example of some of our components. So one of the key things is, instead of building manually based data flows, we use an open source tool to be able to build those data flows. So you can see this is a visual tool, so a business analyst doesn't have to understand any of the different components. They can use this visualization tool in what we call the flow engine, and they can build the flows of the data. And that could involve AI modeling, that could involve using spreadsheets, it could involve PDF files, it could involve data sources. So our system can actually plug in to real-time data sources and manipulate those data sources. We've also got a data marketplace. So what we've seen is companies need lots of data sources. Like in the sustainability case, you might need emissions data. So we provide that. And we also provide an AI marketplace. Again, companies want to run models. So the previous speakers talking about the mining stuff, they might want to, let's say there are 20 different models that you could use. What we do is say, look, we plug those in and the client decides which model they want to use. So this is just a flavor of some of the system and our components and how they work. So again, this is a technology diagram. I apologize for it, but this brings all of it together into a single diagram. So you have the infrastructure, which is in the cloud. You have all the data platforms, and they could be many types of data. We have the data collection ingestion layer, and we use multiple open source technologies to bring that data together. We have an AI analytics layer, and you can either just have a business user using it, or you can have a software engineer building stuff, or a data scientist can use those things as well. And then you have the API, so everything becomes an API. So you can create a component, create an API, and that can be used in any application that you build. And as part of that, I've already talked about the marketplace in the previous slide. And then you need to manage that. You need to manage the users, the profiles, the security, the applications, the components into a single integrated security model. And for us, you need to build it. So if you want to run a component, only certain users will be able to use a component. Well, having the security from top to bottom needs to handle that kind of thing. So what we're trying to do is enable companies to become data-driven businesses by providing the stat, and they can build those data applications that you know, in terms of some of the remit that you mentioned. What we see is this is the way that we can provide it. I've also mentioned the integration, but you know, we integrate to a lot of the systems like SAP and ERP systems and Salesforce. Those are all open source, configurable, integratable technologies. I won't go through any of these slides because they're all techies. How do we start and how do we help you? What we do is what we call find a slice. We find a slice and a use case to work on, and we did because our platform's in the cloud, you can just switch it on. And so as an example, you can build a flow, you can shove it into a dashboard, you can then get a calculation. You can do that in probably days, you know, definitely in a week, a couple of weeks, but you could even do it in days, depending on the data and availability. So there we go. Thank you very much. I've got a case study here, which is, so just as an example, a case study that we did. One of the companies Danone was spending months and months in the statistical and data science team building models, running models. We took that down from 9 months to 2 days using the kind of model I've described to you. Thank you very much.
Thank you, Alpesh. Interesting and really useful information. Any questions or comments for Alpesh from the audience?
They're very quiet.
So yeah, there's a few hands going up there. I just have one. Cool. I have one for you in the meantime. You mentioned sustainability earlier on.
Yeah.
What do you mean by that? ESG related issues.
Yeah, so ESG and sustainability are sort of two sides of the same coin. One of the solutions we're building on top of our platform is to help companies through the journey of becoming a sustainable business. So if you're mining and you're mining materials, lithium, whatever else it is, you know, there's a whole supply chain for that you have to do around embodied carbon of the mining of that materials, all the way through to somebody using that, for example, in their computers or in their batteries. So what we're doing is part of what all of the mining companies have to do is aggregate the data, run the models, and that supply that down the supply chain, because that company will want to do that. So it's called embodied carbon. So if you're building a server, that server will have materials, some of which will be mined. Eventually, you need to provide that data to say, well, we mine this material. Here's the embodied carbon of that material, and that'll be fed down the supply chain. So you need to get that data and have it provable and auditable. So part of our solution, we're actually building a completely separate business on sustainability and ESG to help companies do that. Obviously, within the company, you've got scope 1, 2, and 3. So you have to, every company is going to have to work out their sustainability and their scope 1, 2, and 3. If you're a listed company, that's a big problem. So what we're doing is providing that data platform of how I described to you to help companies do their scope 1, 2, and 3 calculations, and right down to doing what's called life cycle assessments. So an LCA would be an assessment of each of the elements of the life cycle of a product, either that you mine, either companies mine, or products that you use, because you'll use mining equipment and use pens and paper and technologies and cloud, all those data you bring in as what's called scope 3. And we work to do that. We provide that capability.
Okay, thank you. I see the hands have disappeared. So we had some raised hands. They're gone now.
No, I had a question, JJ. I don't know whether it's a compliment or it's raising a concern, because you are talking of an open source software. I was wondering, what measures do you have, like in terms of security vulnerabilities or maybe compatibility issues?
So security is fundamental for us. So we, just to give you the example, right? AWS, Amazon Web Services, use a technology called Kafka. Kafka is open source. Any company can use AWS, it can use Kafka, and it's completely secure. So security is an ultimate thing. So there's a misnomer that open source technology is not secure. The reality is that actually every single cloud provider and every single company uses open source. So Amazon uses open source, Microsoft uses open source, Azure, Facebook use open source. So the reality is, if you're using open source technology, which is industrial strength, and obviously that's what we do. So I mentioned a project, Airbnb created a project called Airflow, right? That is used by thousands and thousands of organizations. You go to airflow.org or airflow.apache.org, you'll see all the companies that use it. So these companies have built this software, open sourced it, and it's used to scale in a secure way. So we absolutely, security is definitely a really important part for us. Data security is and data governance is a really big part. And we embed that security, governance, and principles across the whole stack.
Yeah, it's an interesting conversation because and I know mining is resistant to the word open source, exactly because of myth and but given the OT environment, where we run a lot of legacy systems, what is your view on bringing open source into that environment? And then and obviously there's the added complexity of creating a mesh network. So any thoughts on that, Alpesh?
Yeah, so I'm an architect, right? So I've worked on mainframes, I've worked on legacy client server systems, all the way to modern architectures. So I'm not going to say to you that it's an easy thing to do. Legacy systems are always a nightmare. Absolutely. The older they are, the more hassle they are. The reality is almost every system out there, you can extract data. So whether it's doing an SQL query and dumping it into a file and using that, or actually direct connection to a system, you can do it. Now, there are consequences of that. There are consequences of, because you can't manage it, you can't sync the data, that kind of thing. But the reality is that today, almost every single open source technology we use has connectors into everything. If they're not, you can ask the community to build it. In the mining industry, I'm not an expert on mining industry systems, but I'm pretty sure you have ERP systems like SAP. There are absolutely all open source connectors into SAP. So I mentioned it on one of my slides. SAP, you can connect to SAP in a granular way. So I'm not going to say to you it's not a problem, but the reality is there are solutions out there now. If systems have been around for 20 years, people have built solutions to extract data and push data back into these. And let's be honest, these vendors are forced into that direction. These vendors are forced into say, you need to make your data exportable from the system, whether it's just a CSV file or whether it's a direct connection. Most systems these days can export data. And for us, what we do is in our system, we hide that complexity away. So somebody who's using that doesn't need to understand how that happens. All they need to say, I want to use that data, and they can use it.
Great. Thank you very much. I don't see any other hands or comments in the chat box, so we can move on. Zandisa, next item on the agenda, please. Thanks, Alpesh.
Thank you.
So our next presenter is, it's our final one as well for today, is Emmanuel. Is Emmanuel on the on the call. Ah, there he is. Good. Welcome and thank you. The floor is yours.
Good day. My name is Emmanuel from TOSA Global here in South Africa. I will just hand over quickly to Capino. He will do a quick presentation. Thank you.
Hello, hi everyone. Can you hear me okay?
Yes.
So
we can see you and we can hear you.
So as Emmanuel said, I'm here to present TOSA and present our portfolio. My name is Gabino. I'm the Business Development Director here in TOSA. I overlook the overall business strategy from TOSA. So if you give me a second, I will present my screen. Right. Okay, so we are a Spanish company. We are an R&D company where we specialize in the design and development of high-tech products. We can identify, we can break down all our product line in two verticals. One would be mining, where we have been supplying products for more than 10 years, and logistics. But even though we say that we have like two verticals in our product line, our products are actually horizontal, as we will see later. In terms of our footprint, as I said before, we have our HQ in Spain, but we have presence with local branches in Latam, so in Mexico, Peru, and Chile, and also South Africa. But also we have a partnership with local distributors in Brazil and in Australia. Now, a quick look to our solutions for the mining industry. So this is sort of our portfolio in mining at glance. So in the center, we have our TOSA Cloud, which is our web-based platform where we integrate all our solutions. So we can offer to our customers an integrated experience, so they only have to learn one platform, and by knowing that platform, they can get access to all our different applications and our different solutions. So now, depending on the applications and depending on the hardware that our customers are installing in the vehicles, we categorize the applications in three main sectors. One would be ESG. The other one is around safety and productivity, and the last one is about occupational health. So now we are going to see an example of one of each categories. So the first one would be the ESG. So as I mentioned before, so we have like our products are horizontal. So that means that our hardware is common across the board. So for every application that we have seen before, we have like what we call a core hardware, which is our gateway and our antenna. And just by connecting different other modules, we can turn this core hardware into a measuring machine, or a collision avoidance system, fleet management system, a vibration monitor, etc., etc., etc. So in this case, for ESG, what we have is this architecture. So we have a data logger that will be connected to any sensor that we can find. So we want or any magnitude that we want to measure, for example, CO2, O2, dust. And then we get that information by RF into our gateway, and that gateway will collect all the information from all the different sensors, and then we'll upload that information to our server. So having that information in our server, then all the user using, again, the TOSA Cloud will be able to access that information, and this customer will be able to get the added value that the platform is giving. Because one thing is the information that we are getting from the hardware, but the added value is what you do with that information. So what kind of reporting, what kind of heat map, what kind of processing do you do with that information, so they can optimize the application, the operation, or the factory they are working with. So this is the portfolio that we have for our sensors. So we have temperature sensor, we have humidity sensor, we have pressure sensors where we can measure the pressure of, for example, a clean room. So in case you are working with high-tech technology. But recently we have developed a 420 data logger, a bit more generic. So with that data logger, we can connect any sensor that you can imagine, and then any sensor that exists in order to measure any magnitude that you need to measure. So for example, we have a use case for one of the mines that we work with in Peru, where there's a environmental body that puts sensors around the mines to control the dust. So the mines in Peru are very close to the communities, so they want to control dust very closely, so the dust doesn't go and basically bothers the people in the community. So here we have some graphs of the fines that were put into the different mines last year in Peru. So if you look at the graph in the mining sector, last year there was 170,580 UITs, which is each one UIT is $1,000. So what was $178 million in fines for the mines across Peru. Obviously, not all of them were done to dust, but clearly the ESG is taken very seriously in Peru. So one of the things that one of the projects we are running with that mine is to have our sensor embarked in their vehicle, so they can actually have a heat map of how the dust is moving around the mine, so they can actually go there and send the water tanks to to settle down that dust and stop the dust from going to the communities. So then, apart from ESG, now going to safety and productivity, we have the collision avoidance system. So again, we have our core hardware, and just by adding the different sensors, then we get that core hardware into a collision avoidance system. So in this case, the sensor that we are adding are lidars, cameras, and a display. So, well, a collision avoidance system, our collision avoidance system is based on different technologies. So our collision avoidance system is based on LiDAR 3G, 3D, to get centimetric precision. We also have GPS, high precision. It's a differential GPS that will get you to give you a data with very, very high accuracy. We also implement time of flight and radio frequency for the two vehicles to communicate to each other, and then be able to locate them in the field. And also we implement also network communications. So one of the things that also the unique selling point for our system is that we implement the LiDAR technology, so we are able to detect also untagged objects. So with the antenna that we have seen before, we can talk. We implement the V2V protocol that will make available for the two vehicles to talk to each other, so they can share information like the GPS, speed, so they can actually see each other and know what is around them. But there's another problem, which is the untagged objects. For example, here in the picture we see the shovel that is close to the mining front. Obviously, the mining front is something very difficult to tag, but still you need to detect it because most of the events or interactions that you have in the shovel is with the mining front, and is also an important safety element that you need to monitor. Thanks to the LiDAR, we can get a 3D map of the surrounding of the shovel, and also detect if we are going to be any collision or any risk with the mining front. So here I have a couple of videos we can how we handle the different situations. So here on the right, you have an example of our platform. So basically, you have a dashboard with all the screens that the different operators are seeing. So you can see how the operators are receiving the information. So in red and yellow, sorry, red and green, depending on the criticity of the risk around them, and also they are seeing the distance to the objects around. And also here is an example of one of the situations of the immersed and how the system is handling it. So here on the top, you can see the different displays. So this is an actual image or an actual mirror of what the operator are seeing on the vehicles, and here is a map of how the interaction is happening. So this kind of view is useful, and this playback can be used in case you need to analyze the situation afterwards. So if something happened, or you need to retrain or analyze the situation with your operator, or with the training staff, then you can come to the platform, play it back, and actually analyze how the operators behaved and identify any possible retrain opportunities that you may have. Yeah, this is one of our customers. This is Antapacay in Peru. It's a Glencore mine. And recently, they got this they hit this mark of 2 million working hours without any incidents or crashes. Obviously, this is not all down to our system, but we are proud to be part of this achievement. Now, our last example is about occupational health. So again, we have our core hardware. Now we are going to connect to a vibration monitor. So in the mine, you have many occupational agents. You have noise, you have dust, vibration, diesel particles. Of all of them, one of the most critical one is the vibration. So it's a vibration that the operators are receiving, and that making them unwell, or they may generate injuries in the neck or in the lower back. So one of the challenges that we got from one of our customers some years back was to create a real-time vibration monitor, so they can actually see, they can actually monitor, they can actually evaluate what kind of what level of vibration was being received by the operator, so they can act proactively and before the injury happened. So this is sort of the architecture of the system is similar to the one that we saw at the beginning with the ESG. So you have a sensing element. In this case, is a sensor pad that is fitted inside the driver's seat, so they can actually forget about it, but not forget because we want to do something. What we want them to forget is because we want them to behave normally. So it's not that we are going to do something sneaky with them. It's just we want them to behave normally, so we can collect real and meaningful data. So then that information is then sent to the gateway. So and then to the server, so we can actually using the Torsa cloud, we can actually see the daily dose, and we have different measurements as well that we can collect and we can process. So you can analyze what level of dose that operator is seeing, and analyze if they are getting over the limit. And if they are getting over the limit, we can send them to rest, or we can send them to be checked up. So another thing that we can also get from the data for the vibration monitor is actually our actual heat map. So again, it's good to have this this benefit for the operator, so that we are actually concerned about their health. But obviously, that has to have a second part, is how we pay that. And the way we pay that is by optimizing the different processes in the mine, as in the roads and the maintenance of the vehicles. So just by analyzing the vibrations of the whole fleet, you can work out what is the status of the roads. So here you have an example of some roads which are in green, which means that the vibration is low, and some other roads where the vibration is in yellow, which means that there's a high vibration. So by that, now you have the data in order to back you up, in order to use the resources in some roads and not in others. So previously, this was done by, say, manually. So basically, someone with a pickup will drive around the mine and will identify which roads were not great. So now with this system, you can have it in real time, and you can actually have proper data, which will help you to identify which are the areas that you need to tackle first, so that you can also optimize your resources. So this is an example of the installation of the system, and this information was given by our customer, actually Antamina, which was the first customer that implemented this system. And we can say this data because they told us that they were able to reduce in 80% the report of cervical whiplash and back injuries after the installation of the system. Also, that's the primary benefit of it. But also a secondary benefit of it, so it's basically how they paid for the system, is because they were able to increase the lifetime of the tires by 50%. And here is an example of how the platform works. So here we have the graph of the vibration level in the different axes. And then we can also analyze. So this system has been designed according to the ISO standard 8041 and 2613. In there are 4 levels defined, or 4 measurements defined. So we have the RMS, the VDV, the MTBV, and the AW max. So the VDD so RMS is just a mean of the last second, and then using the RMS you calculate the VDV, which is the total daily dose for the operator. So you can actually work out if they are getting too much vibration. And using the MTBV and AW max, which are the peak values, with those 2 values you can actually analyze if there is any strange event in the mine. So for example, if you are going through a road and you are getting too much vibration, or while loading the truck you are getting too much vibration because they are not following the process or the procedure. So you can analyze with all those 2 values. Yeah, this is sort of some of our awards that the system we have been awarded with. The one that I like to highlight is the People Choice Award, which was provided by BHP in 2020 for this vibration monitor. And that wraps it up. Thank you very much for the opportunity to present our products. And if any questions, please.
Thank you, Gamino. Thanks for the applause there. Question from my side. Do you have any of this equipment in a local South African mine?
Not yet. We are working with some of the mines to start and to run a POC, but at the moment, okay. So we landed in South Africa last February, so we are fairly new to the market, and they are now trying to have basically to have our first customer.
And the hardware, the core hardware that you're speaking about, is that proprietary to Xhosa?
Yes,
so
we design and manufacture hardware
system.
and software. Yes, it's our own system. Yes.
Great. I just want to check the comments here in the chat box. Thanks, Alpesh. So those who want to connect with him on LinkedIn. And then obviously, you know that in South Africa at the moment, TMM level 9 compliance is it's not only key, but it's actually mandatory.
Yes.
How does your equipment meet up to that standard?
So,
from a collision avoidance perspective.
Yes. So our core hardware has 2 canvases, and both are compliant with the ISO 21815 standard from 2022. Okay. So yeah, we are level 9 ready.
What I did like, there was that one slide you had about benefits and productivity. I'm not too sure whether the data that was generated from your collision avoidance system actually by accident provided data that would actually help one optimize and improve, the heat map that you showed, or was it actually intentional?
Was intentional. So that's one of the things that, because you have the GPS at the end of the day, you have the data there. So you have the GPS and you have the vehicles running around the mine. So it's sort of a no-brainer to have that heat map. So but I like to say that was our idea, but it was actually our customer's idea. They told us, look, you have that data, can you produce that? And we did it for them.
Well, that's fantastic, because that's where data was used to gain additional insights. Over and above its maybe rudimentary or original purpose. I see a hand here. Just want to track it down as to Mzwandile. Yes.
Hi, JJ. Can you hear me properly?
Mzwandile. Yes.
Yes.
Can
No,
hear
thanks
you.
for the presentation. Very interesting.
Thank
I
you.
think that the one thing I just want to touch on is with the amount of data being generated, and I hear proprietary systems, who's the custodian and owner of the data to further explore big data integration of other systems? Who's the custodian of the data being generated?
So the data belongs to the customer. So it's their data. So the data owns to them. And then in terms of how we implemented the data integration is we can do it in the cloud or on premises. That will be down to the customer how to do it. Is depending on the security requirements. But also we are again open to connect to the system if they allow us to do. For example, in some mines, we are allowed to connect to the dispatch to get information from the operators. Some of the mines are a bit more restrictive on that perspective, and they share that information using CSV or other ways to do it. Some of the mines, they don't allow us to connect to any of the systems, but they get the information from our system using CSV or an API, and then they do their own dashboards and their own integration.
Thanks for that.
Good. I don't see any other hands or comments. So thank you for that, Camino.
No problem.
Zwandile, I just want to check if we're on the agenda, that we haven't missed anything.
Are you asking me, JJ?
Oh, sorry,
Oh.
Zwandile, sorry. Zandise. Okay, so yes.
No
So
worries.
everyone, we've reached the end of our event for today. It actually went quicker than we expected. Thank you very much to the presenters. I think some great takeaways that we can go and consider and process. If you don't mind sharing your presentation deck with us, or decks, then we can circulate it to the audience, and then this recording will also actually go to a wider audience, because we have a wider audience than just the 25 or so that are on this call. And so we would like to actually make the recording available to the broader audience, which will be useful for yourselves. I think there was another hand. Yes, Gordon. Gordon?
Sorry, JJ, my mistake. Sorry, apologies. No hand. I'll drop it down.
Okay, no problem. Yeah, so there's an invitation to connect with Kim as well, Alpesh, and I'm sure with the other presenters as well. So again, on the final conclusion, thank you very much for the presenters and the audience for attending, and feel free to reach out either to ourselves or to the presenters if you want more information. Thank you, everyone. Have a good day.
Thank you and goodbye.
Thank you. Bye.
Thank you very much.
Thank you.
Bye.
Thanks.
Thank you very much, everyone.
Thank you. Bye.
Bye. Thanks, JJ.